new video now, not on the trainer itself, but inside the e-learning course of our ACE-EL3, or in general our hybrid safety trainer. What you see here is basically the interlock of electric vehicle, hybrid vehicle, doesn't matter. It's one way how you can create an interlock or do the interlock in a high voltage system. And of course, it's pretty hard to see them from the outside. As you see here on the right hand side, you have three different components. They are part of the interlock, or more the connectors or around this, they are part of the interlock. But like I said, it's really hard to see the whole thing itself. And this is why we've created here this animation. And you see, basically it is pretty easy. There's not much needed. You have a few components regarding the voltage supply, or basically the current supply, that you have a stabilized current basically. You have a microcontroller unit here which is doing the calculation basically. And the other thing, it is just voltage and resistance. So basically pretty easy. You see, we have here different kind of resistors inside, and in the normal case, so that means when all the connection, like from the inverter, the service disconnect plug over here, or even the air conditioning compressor, when they are connected as they should, you see that these resistance, which are parallel to this connection, are bypassed basically. So it doesn't run over these resistors here, as you see the red lines. And basically, the voltage which you have, or the voltage drop which you have in general, you see over here. So that's the 1.5 volt in that case. So you have here a general resistance, which is always there, and you have another one which is behind the actual interlock, which you see inside here, this R7 basically. So now really interesting for the interlock itself are these three resistors. And now you see what happens when I, for example, disconnect the inverter. So we have interrupted the interlock here at the inverter, and you see now the voltage or the current flow is over the resistance. That means we have now another resistance inside the circuit, which leads here to another voltage drop, now at 2.5 volt. Now we can connect this one again and disconnect this one. There you see, same thing, but different voltage. And just to make it complete, here as well. So there you see now, as we have different voltages, the system can directly say where the interruption of the interlock is. And that not only works because you have always different voltages or different resistance, as you see it here, you can also disconnect multiply components, and the interlock will be able to recognize that, as this is also again individual voltage value, which defines exactly that case that the inverter is, the interlock of the inverter is opened and the service disconnect is unplugged basically. So when we pull that as well, you see again a certain voltage. So when we connect this together, everything is back again at the normal condition. So let's have a look now, a closer look at resistor R1 and R7. So R1 is basically pretty easy to explain. When the interlock is in place, so that everything is connected like it is now, you would need a certain resistance outside these three others, which make it possible to measure the normal status basically. Okay, so basically R1, the resistance which you have now through R1 is this 1.5. It's also in connection with R7 of course, but when you have this value, they know everything is fine and the interlock is in good condition. Because when you have some kind of short circuit, then everything will be bypassed over here. This is then the case when only R7 is available as the resistance inside the circuit. And when you got that, so basically when you have this malfunction or this broken interlock, that's difficult, or that's necessary to recognize, that you then can say, oh look, the value which I have now doesn't mean everything is okay, but it shows us that the interlock is broken or has an internal short circuit and bypasses all the resistance. And that means when that then R7 is the only resistance, and with the corresponding voltage, it will tell you that your interlock is broken and you need to repair it. Alright guys, if there are any questions, just let me know. Otherwise, I hope you enjoyed the video, and yeah, thumbs up. And if you have more wishes for other topics, just let us know. Have a good one and goodbye.